Right then, cloud gurus. We write our code, stash it in an image, and that image runs as a container. Only Kubernetes doesn't let us run naked containers. No, we have to dress them up as pods. And pods are cool and all, like they open up the world of sidecar containers and things like service meshes, which genuinely are the bizzo, but they don't do anything for us on the scaling or application release fronts. For stuff like that, we need a deployment. So right out of the gate, deployments are higher level objects than pods. In fact, the same way that pods wrap containers, we could say that deployments wrap pods. As well though, they are all about scaling and updates. That's the basics. Only, actually, behind the scenes, there's also something called a replica set in play. So the replica set sits in between the deployment and the pod, and then it's the replica set that actually takes care of any of the mechanics of scaling related operations that the deployment kicks off. But you know what? You rarely see them, because they're managed by the deployment, and it's the deployment that you'll be interacting with, or at least you should be. Anyway, on this concept of wrapping a pod, a deployment manages a single pod. How to say this? So, it's not like you can have, and let's just say for simplicity's sake here, right, a web pod and a database pod and put them in the same deployment. No, you can't do that. In fact, you know what? If we throw this up here, we'll be able to see it better. Right, so this is a deployment, and this is the pod it's defining, a single Redis container. And this bit up here is the scale bit. So right now, this deployment is asking for a single Redis pod. And if we increment this to 3, what we're going to get is 3 carbon copies of the Redis pod, 3 identical pods. Now, to do this, the deployment updates a replica set that it's using behind the scenes, yeah? Remember, deployments don't actually do the legwork of scaling. That's the job of the replica set. But that's the deal, right? A deployment takes care of running one type of pod. If we've got another part of the app running like Logstash or something, then we'd need another deployment. And I don't think I've mentioned declarative yet, so I better scratch that itch. The declarative way to manage deployments is to make every single change that we ever make it in this file here. Then post it to the API server and store it in version control somewhere. So, like, if I want to update the version of the image here, well, I'd check this exact file out of version control, make the change to it, post it to the API server, and then check it back into version control. And it'd be the same for scaling, or any change in fact. Make all of your changes to this file and post the updated version to the cluster. That way, right, your manifest here is always going to be in sync with the cluster. So it represents your desired state, and it's the job of Kubernetes to make sure that the actual state of the cluster matches it. So documentation actually matching what's running in live? Shall we start that victory dance? Yeah. Anyway, let's look a bit closer at updates. So this strategy section here tells the cluster how to go about updating the live app anytime we make changes. So if I did change the image version down here, maybe the old one had a bug or something, well, we're defining a rolling update. That's the default, by the way, and to be honest, it's the only one worth mentioning. But what we're saying here is, well, we've got a desired state of 3 to begin with. We need to know that to be able to understand what's going to happen. So we want 3 replicas serving the app, please. And then what Max Surge here says is, okay, while we're performing an update, we're allowed to surge up to 1 more pod than the desired state. So for us, we can go to 4 during the update, yeah? Max unavailable here, that's similar, only this one is how many we can go below desired state during an update. Well, this one's saying never go below desired state. Anyway, it's a rolling update, right? So when we kick it off, it'll fire off a new pod with the new version, taking us up to 4, 3 with the old version, and now 1 with the new, yeah? And we can go to 4 because of Max Surge here? Well, once that new one's up, we'll take one of the old ones down, and that'll bring us back to 3. So far so good, yeah? 3 in total, 1 of them's got the new version, and 2 still have the old. And to be honest, that process just repeats itself until they're all up to date. Only, this value here makes us wait 5 minutes in between each one. So we bring up a new pod, wait for 5 minutes to make sure it comes up and it doesn't fail. Assuming all's good, then we crack on with the next one. So add a new one up to 4 again, take down an old one back to 3. Bring up a new one, take down an old one. And that is the deal until we're back to all 3, all running the new version. And if your clients can handle a change like that, this is a zero downtime operation. Love it. Now, behind the scenes, to perform the update, remember, there's a replica set. In the beginning, that holds the original 3 pods. Well, to spin up the 3 new pods, the deployment creates a new second replica set for the new ones, and it starts incrementing that as it decrements the one holding the old pods. So adds one to the new replica set and takes one away from the old, and it just rolls through all 3 like we said. Which, on the topic of replica sets, while we totally can see them and manipulate them, we shouldn't. Like, if I was to delete the replica set with the 3 pods, before I could say, "A Cloud Guru for the win," the deployment had just wind it back up. Because remember, the deployment still has a desired state registered on the cluster saying 3 replicas please, and if I break that by hacking down the replica set, it just self-heals. So deal with the deployment, never go directly to the replica set. As well, right, how does the deployment know which pods in the cluster it should be managing? Answer, labels. Now, if you don't already know, labels are at the heart of Kubernetes. In fact, I'd almost say no labels, no Kubernetes. They really are that powerful. So, our deployment here is loosely coupled to any and all pods on the cluster with these labels, or this label. So you could, if you wanted, I guess manually add pods with this label, and yep, they would definitely be managed by this deployment. But the problem is, if you did that, well, you'd be taking the replica count above 3, and the deployment only wants 3, so it'd just terminate them. So yeah, don't do that. But you get the point. The only thing linking this deployment to pods in the cluster is labels and a label selector. Okay, just a couple more things and then we'll do the demo. So it's basically anything in this spec.template section here that triggers an update. So change any of these values and you'll kick off a rolling update. Anything outside of this highlighted area, like the obvious ones, the replica count, sure, that's going to trigger more replicas, but it won't be a rolling update, so none of the existing pods will get replaced just by upping the replica count. But it does mean that if you were to add an annotation in here, that'd trigger an update and pods would definitely get replaced. So yeah, good to know. And last but not least, if you've got an update currently in flight and you post another update to the cluster that supersedes it, the in-flight one gets dropped and the cluster cracks straight on with the new one. So there's no waiting for the current one to finish and then picking up with the latest. No. Anything currently happening on this object, obviously, well, that gets dropped and the latest config gets directly applied. And with that, demo time.